So in this session, we are going to talk about different data encoding methods in machine learning. So here, I'm going to have a data set and loading that using pandas. So importing pandas as PD and also importing NumPy as well to create a multi-dimensional array. So these two libraries are imported, and then my file is Excel file. So importing it using the function pd.readExcel, then displaying the header part of the data. So here we have three columns: temperature, color, and target. So no machine learning algorithms works with categorical type of data. So whenever you are building machine learning model, so you should convert your categorical data into numeric. So that is the agenda of today's session. So we are going to talk about different data encoding methods exist in machine learning. So I'm checking the data types of this. So these no first two columns, temperature, color, these are object type, means categorical type, and the target variable here, target is numeric, so it is integer 64-bit type. Next, I'm checking the shape of data. So we have 10 rows, 3 columns. So one of the first encoding method is label encoding. So what it is going to do is it just convert your categorical values into numeric starting from 0. For example, let's say you have a data cold, hot, very, very hot, and warm. So these values are encoded into 0, 1, 2, 3 in alphabetical order. So I'm just checking the number of unique values in each column. So temperature has 4 unique values and color has 3, and target has 2, only zeros and ones. So for us important is temperature and color. So on the temperature, what are the values, unique values? So in the alphabetical order, first cold comes, right? Next hot comes, next very hot, then warm. So label encoder encode these values as this one is 0, 1, this one is encoded as 2, and this is encoded as 3. So 0, 1, 2, 3. In color, you can see how many unique values are there. So as we have checked here, we have 3 unique values, which are starting from B. So blue, then red, then yellow. It means blue is encoded as 0, then red is encoded as 1, and yellow is encoded as 0, 1. This is 2. So we are importing label encoder from scikit-learn.preprocessing. So once it is imported, next we can create an object to the class label encoder, and we're going to have a new column, that is temperature label encoder, which is equals to label encoder dot fitting data and transforming. What is the column? You are transforming temperature column, and also you're also converting color column, means we are encoding temperature as well as color columns, and we are going to create new columns with these names. So let's see the data after conversion. You can see the new columns are created. The first one is temperature label encoder. So cold is encoded as 0, then hot is encoded as 1, then very hot is encoded as 2, and warm is encoded as 3. So if these values are repeated, then the same numbers can also be repeated. For example, here cold again, so 0, hot again 1, hot again 1. Similarly, you are encoding color. So in color, blue comes first, so 0 here, right? Next red 1, next yellow. If these are repeated, then same numbers are used. So this is the use of label encoder. So it always encodes the categorical values in alphabetical order. We can also use pandas factorize method, pd.factorize. So importing the data again in order to avoid the changes that we have made, and then applying the factorize method on temperature, right? Accessing the values and reshaping the data to -1 and 1, and then looking at the data frame again. So you can see the new column has been created, and then the values, how the values are encoded, like 0, 1, 2, 3. So in temperature 4 values, so 0, 1, 2, 3. So 0 is assigned to the first value, that is hot. Then next encountered cold, then 1. Very hot is encoded as 2, and warm is encoded as 3. So the same numbers can be repeated. Next, the second method is one hot encoding. So when you have categorical data, so you can also apply one hot encoding, but for each unique value, it is going to create a new column. Okay, this is the point to be noted. It maps each categorical value. Uh, if the value is present, then it assigns 1, otherwise 0. So denoting the presence or absence of the feature value. So this method produces lots of columns. So this is going to be a drawback. So when you have some hundreds and thousands of unique values, then it is going to create hundreds and thousands of unique columns. So the dimension of the dimension of the data increases. That means your data can become complex data or high dimensional data. So that is going to be a drawback. So what is the drawback is, it is going to take the processor time. So model building will be slower. So I'm importing the data against the same data. Then before applying one hot encoding, we can also use pandas get dummies method. So this is similar to the one hot encoding. So what the get dummies method will do is, for each unique value, it will create a new column. Sorry. So in that, if the value is present, then 1. If the value is not present, then 0. So this is the prefix we want to have for the new column. And we are applying get dummies method on temperature column, and then you can see the conversion. So in temperature, we have 4 unique values: cold, hot, very hot, warm, temperature. Okay, temperature, warm. So you can see the first value. What is the first value? The first value is hot. Okay, so if the hot is there, then 1, and these values are not hot. Got it? These values are not hot. So 1 means present, 0 means not present. Again, I am loading the data, and we can also do the same by using one hot encoder. So one hot encoder and get dummies methods are almost same, but the values of the data frame are going to be float. So as you have here integers, zeros and 1, but if you apply one hot encoder, it no gives you the values 1.0 and 0.0. So importing one hot encoder from scikit-learn.preprocessing, then creating object to the one hot encoder, then fitting data and transforming the data. So we are converting the values of temperature column and finally converting that into array, and then appending the converted values to the original data frame. So data one hot, which is user defined variable, which is equals to pandas data frame to the old one. You are applying the new converted values. So the columns, so it is prefixed with temp underscore. So based on the categorical value, you convert all the values, and then finally we can see the concatenation of actual data and the converted, and displaying the data frame. Here again you can see 4 new columns are created. The prefix for these columns are temp underscore, and if the value is present, then 1.0, otherwise 0.0. That means the second row is cold, right? The first row is hot. So this is the conversion of categorical values. Then the third method is ordinal encoding. So when you want to maintain an order strictly, sometimes if you apply label encoder or one hot encoder, so the importantly label encoder, the order might be changed, right? In that case, you can prefer ordinal encoding. So importing pandas as PD, then creating a data frame again, and I just want to maintain strict order. So I'm creating a dictionary here. Temp dict. Cold is 1, warm is 2, hot is converted to 3, very hot is 4. So label encoder by default it starts from 0, but one hot encoding you can start from any value. So I just want to start with 1, 2, 3, 4, and then applying the mapping the values. So data dot temperature mapping with dictionary, then showing the data frame. So you can see the new column is created, temp ordinal, and the first one, right? What is the first value? Hot. Hot means 3, and the second value is cold. Cold means 1. So based on the dictionary you mentioned, the values are mapped. So this is the output. And binary encoding. So binary encoding converts categorical value into binary digits. Okay, it's going to create categorical values into binary digits. So if there are n unique values, then binary encoder will result a log base 2 to the power n. So for example, hot, it is order is 1, so which is encoded as 001. So you are going to have 3 columns to represent these 3 digits 001, and cold is encoded as 2. So in binary this is 010, so 3 values 010. Similarly, very hot, the binary value of 3 is 011, so 011. So let's implement this. Loading the dataset again, and this is not part of scikit-learn, so that's why you need to install. So pip install upgrade. If you don't have this, then even if you have it, it will upgrade. So hyphen upgrade categorical encoders, then after installation you can import it. Right, in my case I'm already having this library, so that's why not installing. So importing category encoder as CE. So this is alias, short name. Then creating object to binary encoder. So the column which is fitted to the encoder is temperature. Then fitting and transforming the temperature column. Then concatenating the original data and the converted one. Then displaying the data frame. So you can see temperature hot. It is encoded as 1. So 1 means 0, 1, 1. Then cold, it is encoded as 2. So 0, 1, 0. Very hot is encoded as 3. So in binary 3 means 0, 1, 1. Warm is encoded as 4. So 1, 0, 0. So if these values are repeated, then the same digits are used. So this is about encoding. So most of the time, so we use label encoder, right? Most of the time we use label encoder, and if you want to maintain order strictly, then you can go for ordinal encoding, or if you're no, the number of columns is not a major concern, then you can go for applying get dummies, pandas get dummies method, or one hot encoding. So which is imported from scikit-learn.preprocessing, create an object and convert. So these are the widely used data encoding methods. So we discussed about 4. The first one is label encoder, the second one is one hot encoding, the third one is ordinal encoding, and the fourth one is binary encoding. So this encoding comes under data pre-processing. So once you have loaded the data, you need to check the info. You can apply info method to see what are the data types of your columns, and then if they are object type, then you should convert. Otherwise, you'll be getting error when you are building a machine learning model. So that's it from today's session. So feel free to research with any comments, and do subscribe the channel for more relevant updates.